All right, guys, let's get started. Welcome, everybody, to Patricio Cofre's talk. Patricio is one of our distinguished alum from the Master of Engineering Management from 2013. So he literally graduated 11 years ago. Patricio's career has been amazing. We've been able to watch it from afar. Patricio's obviously from Santiago, Chile. He was one of a handful of Chilean students we had roughly in that time frame, thanks to Becas Chile, which was a government program that funded students to come here from Chile. Patricio has been working in what I guess I could summarize as data consulting. I think data consulting summarizes his career probably pretty well for the last, 17 years?
Yeah.
And almost all of it at EY?
Yeah. 5 at EY.
Okay, 5 at EY. Okay, so if you worked on the Accenture Analytics competition in your day, which was an amazing project that we had where Accenture brought data sets to both MEM and at the time MSIA.
Good that you remember that.
And we actually had MEM and MSIA competing against each other to see how they would solve the same problem. And it was fascinating to watch the two programs attack the same data set from different perspectives. So I don't know if that's part of your talk, but it's something that I remember from the day. You worked on a Cisco routing project. You've been a lecturer at the Pontifical University of Catholic University in Chile for how many years? 17? 17 or 18 years. That's a long time. So, I mean, we have I guess we're very fortunate to have Patricio with us today. So let's give him a round of applause and thank him. And I want to give you hands. Okay? And I'm going to sit down over here.
Oh, thank you very much, Mark, and Joe, and everyone for being here, for being interested in that topic. And for me, it's amazing to be here. 11 years back, I was in this very same room. Most of my classes were here, so it's really emotional for me to be here. So thank you so much. And what I will talk about is about AI. Of course, it's the topic of the moment. It's the technology of our times. And I've been involved on that since I went out from school in Chile, and I started my own company at that time. Actually, when I came here, I have already found my company, but it was relatively small, relatively short reach, only within Chile mainly and Argentina sometimes. But the program for me was very, very special in terms of opening the world for me, opening the ability to interact with more people, with more countries, with more economies. And fortunately, my company was able to grow when I went back. And it was finally in 2019 acquired by Ernst & Young. And that's where I'm working now for the last 5 years. Okay, so here is I'm AM 2013, and today I lead the AI practice in EY for Latin America. So now my reach is not only Chile, Argentina. Now I'm covering the rest of the country. It's a big responsibility. There's many countries that you need to coordinate in order to work together. But it's very also rewarding to be in that position and enabling many people, many young professionals that are getting consulting to get into that. Because it's not a very mature practice. AI is very new. It's something that is still being defined, and we need to try to capture this first instances and try to convert into productive assets within our company. So it's a big responsibility to take an immature technology and put it into production with clients. This is the job we are doing. And here's my LinkedIn. So we please let's connect to keep the conversation. Okay, so I'm gonna divide my presentation into this topic. First is to tell a story of AI. It's very important to tell the story, to understand what are the bases. As Mark said, it's all about data, and to understand the databases is very key. It's paramount in order to understand what is happening now with AI and where it's heading. Second, I'm going to talk about generative AI. It's a 2-year technology, let's say. It have a little bit more, but publicly available is just a 2-year technology. And it's amazing what we are seeing and what we foresee for the future in the company. Third, I'm going to talk about applications. This is what we do. We do applications. This is what we are taking to the market. Then I'm going to talk about management, because this is our specialty. We need to talk about management. What are the techniques of management that we are applying in AI? And finally, let's talk about responsible AI. Yeah, because this big opportunity we have one responsibility together. And this is a responsibility we need to take. And this is taking the shape of a framework for responsible AI. Okay, so the first idea I want to convey is this idea of fourth industrial revolution. Probably we have heard this many times. But why I think it's important? Because it's a little arrogant to say we are in the fourth industrial revolution when we're still living it. You can tell the story many years later. Probably in 20 more years, probably we'll be able to say this is a industrial revolution. And more arrogant is to say 2015. But we'll see the story will tell that. But we are seeing the same impacts that all the industrial revolution. First, the first industrial revolution was where the human was able to control the use of the steel, how to store it, how to compress, how to release, etc. But when the mankind was able to do that, the mankind was able to move faster than it used to, move farther than it used to create biggest and move biggest loads that it used to have. So the humanity grew in terms of capacity, productive capacity, but it's not only a productive revolution, it's also a social revolution, because at that time, those that concentrated the power of this technology started to gain power in the society in general. They started to give they concentrated some power to eventually compare with all the inherited powers of the princes and etc. So it was a revolution in the productive side, but also in the social side. Electricity, when we managed to control the electricity, to domesticate somehow the electricity, we were able to concentrate production. And when we concentrate production, productivity increased, but also the society changed because we created the cities, metropolis, and we started to concentrate the population with the goods and the bads of that. Third, computation. When the computer appeared, we, for the first time, were able to give an instruction to a computer, to a mass of plastic and metal, give instruction to a piece of inert material. Wow, that was crazy. And of course, productivity increased a lot, because we can make this pile of wood, plastic, and metal instruction to work while we were sleeping, etc. So productivity, of course, increases. But the society also changed completely, because today there's no job that at some point is related with some piece of computation, right? So why we think AI is an industrial revolution? Why is not just an extension of the third? And the main argument is that for the first time, the instruction is not explicit. At some point, the instruction started to be implicit. All instructions that we do in the computer area, we need to know the basic principles. We need to know the rules. We need to know the formulas. We need to know the process, at least, to understand the concept of process, and I can instruct them explicitly to a computer. But if you don't have that, how can you program a computer? And this is where AI is so different, because for the first time, we will not need to write every line of code. we just need to provide examples. Many examples. And somehow, by giving examples, giving some premises and some consequences, some X and some Y's, and eventually they will connect the network will set right itself. And these are two big implications. First, that for the first time we will be able to solve those problems that we do not know how to solve, which are, in my experience, the biggest part of the problems. 99% of our problems we do not know the basic rules, the basic formulas, the basic principles that run that process. But second, is that every machine that is self-written, eventually, at some point, will go against our human race. And eventually will be racist, eventually will be sexist, etc. And of course, there are already examples of that. Right? So those are the two biggest implications, and that's why it's a productive revolution, but it's also a social revolution. And this is why we think this is an industrial revolution. To tell the story of AI, we need to start by telling the story of data. And in data, we have seen three main ways of how we capture, manage, and exploit the data. First, in the 80s and 90s, we were able to collect a lot of data in the first digitalization era through the world-class systems like ERP, CRM, payables, payroll, all the regular system we have in our computers. And even though some companies were very successful at that age in digitalizing all the units at the company, they were missing a lot of stakeholders because in here they are only digitalizing the internal operation. But the internet was the point where they, for the first time, started to capture info about the regulator, the government, the public opinion, the competitors, the providers, the client. For the first time, they have first-hand data about the client, right? So, but this required to create new technologies because the traditional database technology was not able to support the growth of the internet, social media, etc. So we need to change the paradigm in technologies because we are not talking about gigs and teras, we were starting to talk about peta. And right now, we are at the big data era. And what's big data? Big data is, for me, the definition is all the context, all the intention, all the hidden points of the ERP. Its intention, its desire, is the scattered things that the ERP not capture. Because this coffee probably cost me $2. And someone in the same moment bought the same coffee of $2, but the feel might be completely different. I was with my family and we stayed in that place. We have a very fun moment. Another guy can have both. In the ERP, probably is an SKU, a data point, and a price. That's all what the ERP is saying. But experience is much bigger than the 3 points of data. And this is big data. Big data is, imagine this room. Probably this device is logging all its operation, and the camera, and the zoom, and the heater. Every device is capturing data. And even though you don't need to do the analysis of how the correlation, blah, blah, blah. You just capture data. And at some point, if you want to measure the success of this class, of my speech, or whatever signal you want to measure, you can take that into consideration. And eventually, you get a more nuanced version of this predictor. And this is the success behind Amazon, Uber, and all the apps that we are using. They are very, very precise, profound in using data. They are leveraging all the log that our visits to the website are giving. For example, I didn't know, but the browser today also track how much battery is left in your computer or your mobile. And you say, ah, does it work for something? Is it useful? Well, eventually, yeah. Eventually, it's depending on if I'm using the speaker or a headphone or how much battery or the power or the signal level that I'm getting, of course, require a change of experience. So Amazon is changing the website, changing the app by taking the signals, right? So this is a good example of big data. What you see in the x-axis is the Moore's law, right? So in the 80s, to have 1 giga cost $190,000, $9,000 in the 90s, $15 in the 2000s, 7 cents in 2010, and now in any cloud, you get 1 giga for 1 cent, right? So this is a Moore's law. Any of you remember what the Moore's law said? It's we're doubling capacity every 18 months, right? Double capacity in half of the price every 18 months. And yesterday I was in the Microsoft conference. Satya Nadella said, we used to have double capacity every 18 months in the Moore's era. Now we are doubling capacity of AI every 6 months. So it's speeding up somehow. It's not the same because that was how many microprocessors you have in a chip per inch square. Now it's a little different, but it's a good analysis. We are doubling capacity every 6 months.
Patricio,
Yes.
I wanted to mention that Chicago is the site of what Argonne has implemented called the array of things. So it's IoT on steroids. There's literally sensors throughout the entire city of Chicago capturing CO2 levels, oxygen levels, pollution, noise. So every sensor you can imagine has been arrayed together to create a huge data set for the city.
Amazing. Other good example of that.
Exactly.
Big data.
Right.
Big data.
They don't have an immediate need for it.
Exactly.
Right. But they anticipate maybe there will be, right?
It's the same that I said with the battery level. You don't need to right now have an idea on how this impacts, but definitely it's useful. And you will see the successful companies are leveraging this amorphous data and not necessarily understandable data, but somehow things get connected, not necessarily by a human coordination. Eventually, the machine will find a way to make it useful, right? This is the message. Okay, so 3 areas in data capturing. First, the ERPs. Second, the Internet 2.0. And third, the big data. And in analysis, we also have seen 3 big waves. First, business intelligence. Yeah, so this is the point where in companies we realized that we were hiring data analysts or business analysts that Monday, Tuesday, Wednesday, Thursday, and part of the Friday were only getting data, cleaning data, arranging data. And Friday afternoon, they send you a report. Hey, here's the report. Good luck in the board of the directors. How much analysis do that have? Nothing. We were spending most of the time in exactly the part where the computers can help us the better. And we are spending just half a day in what makes us human. Doing analysis, making connection, making a call, conveying a message, creating support. So BI for me is the point where we decided to spend the Monday on preparing and arranging data in Tuesday, Wednesday, Thursday, Friday, thinking, connecting, persuading others, conveying a message, creating teams. This is analysis. And in order to do that, we had to create a new instance of data. And that was challenging to tell that story in the 90s and in the 20s. You need to invest in a different hardware, in a different technology for that? Yes, you have to. Because transactional systems are not thought for analysis. They are thought for capturing, to be redundant. They need to capture redundancy. But here we cannot accept redundancy. We need to have a single modeling of all the data in order to avoid two questions in the company. First, where did you take that data? Now company should be asking that question. Everything should come from the data warehouse or the data lake or you name it. But to keep talking on where did you take that data, it's not useful, it's a waste of time. And second, what was the calculation you did? What's your KPI? How did you calculate it? Well, the calculation need to be already embedded here. Okay. So this is a very consultative process. It takes time, but it's a process of consensus, of agreement on what margin is for you, what a student needs for you. There are usually many definitions, but you can do this job and eventually get a central repository for all the analysis. So to operate, use that system. To analyze, use that system. And this is what BI suggests. And by doing that, you can start doing all the reporting of the company from the data warehouse. No longer use straight to the data sources. Let's go to the data warehouse. And we started thinking on advanced analytics, not only to make the question, but eventually trying to find a question that you never asked yourself. Right? So first data is BI. And one of the biggest outcomes and legacy from the BI is that we stopped seeing this type of charts in our books, in our slides, in our presentation, because you can show exactly the same that way in a very visual way that really use our human vision that was developed during millions of years, right? So our eye is able to capture texture, forms, colors, tones, etc. And that produced two things. First, a much better understanding of what I'm seeing. Because I'm not an expert in Costa Rica exportation, but I can tell, wow, they actually export a lot of banana. But look what we did in medical instruments, orthopedic appliances, integrated systems, electrical parts, semiconductors. They are doing semiconductors in Costa Rica. Wow. First, I can tell a story only by looking at the chart. But second, it can break my preconceived idea. And this is the most profound thing BI can do. I can change my preconceived ideas. Second way in analysis, data science. Because even though you create a perfect business intelligence that can give you answers to any question you can make, you just do a question, whatever question. And the good thing is that this is an answer. It's completely cold, have no blood, no hormones running on the body. So you can ask whatever political question you want to make. Okay, are your students that okay, and this will answer you straight from the data, the result. So you suggest the hypothesis, and some chart will give you the answer, right? But what happens if you, even though you have a good pattern, okay, I found a very good pattern to understand what are the students. What if you ask, is this the best pattern that I can have? Is there another pattern that eventually is a little better than mine? And this is data science. When you start from the cases and you end up with a pattern, you end up with a question. So we somehow change the order of the elements. We start from the question, we get an answer. Now we start from answers, and eventually we get some good questions. And some of these questions eventually surprise us, are completely out of our preconceived ideas, etc. So this is very, very important. But think on it, data science, the goal of data science is to have good patterns. And a good pattern is a pattern that I understand. And this is how we get to AI, the third wave of analysis. AI started as a thought branch of it's a philosophical matter in the 50s when Asimov wrote his books where Turing was experimenting just theoretically because they don't even have a computer, right? So they were thinking on what would happen if this table of plastic, wood, and material eventually start to think and develop some human abilities, like learn. This can learn. Eventually, yes, this thing can learn. And they do the whole thought process on that. They hold the rules of robotics, among other things. But in 1997, it happened one thing, one very, very special thing. And it was for language transcription. In order to do voice transcription, this was a thing that was until the 1997, the researchers tried to program the voice transcription. And they use very, very different techniques by using the frequencies, by using trying to find a pattern of the word love. Love, 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 love. And they're all the same. But they were not able to program a machine to translate the word love, in the 4 letters of love. In 1997, they, for the first time, they said, okay, let's stop programming this. It's no product, it's not getting anywhere. Let's try to train. And this was the first result of a machine that worked better than the programmed version in the training version. Right? So for the first time, we have at that point, still regular robot transcription, but working as well as the program version. And this field started to grow, and we started to require the machines more precision. And the machine gave us more precision. And we required more precision. And the machine gave us more precision. And we again asked more precision, and we got more precision. And we get into a very dark and black zone called the deep learning, where the algorithms and the models started to become completely illegible, impossible to understand. But we got all the precision we required at the point that we have an autonomous vehicle running in our city, right? So we got all the precision we want. Wow, it's amazing. But what was the cost? There were a cost. Did we pay something for that?
Environmental change. It produces more heat, it requires more water.
Okay, yeah, so in sustainability, of course. We pay something, of course. But in this term, the biggest cost was explainability. Because at that point, in in linear regression, in logistic regression, we used to understand what we do. We used to understand the parameters of the model. Now we do not. So we pay in understanding, right? But who cares? Who cares if we do not understand? If I take my phone out and the gyroscope understand that I'm trying to tell, it turned on the camera, look at me, and unlock the mobile. That's all what I want. So in terms of experience, probably I want the deepest of the deepest of the deepest of the learnings, because I want a very good experience, right? And it sounds magical, but we do all the things. And I'm not gonna go, hey, tell me why you did that. I want to log all the things you did in order to unlock my cell phone. No, I just want to experience. But there are many other fields where we will require an explanation. If a judge wants to take your home or your son, you will require an explanation. If a bank rejects a credit for you, you're a small startup on the globe, blah, 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 you need an explanation in order to prepare them for the next time. If you're a student, you need feedback in order to keep learning, right? So there are some spaces where we will need an understandable explanation, and this is the aside. So why I'm telling this? Because all the ways do not cover the rest or eliminate the rest, the other previous ways. They're all still needed. Will we need BI? Of course we need BI. It's the biggest part of the analysis. And we'll always need BI. Okay? And within deep learning, there's a technique called generative AI that for the first time allows us to create. Not only to classify, because all the previous AI were classifiers, right? So you will be a good payer of the loan, you will be I don't know, you are spending or you are seated, blah, blah, blah. Every classification was the specialty of the deep learning, the first deep learning. But now we have the ability to create a reality. Somehow, the previous AI where you take a reality and you get attacked. Now let's start with the tag, and eventually I suggest a possible reality that created the tag, right? So it's somehow you change the order of the elements. Okay, so how the AI works? And you will understand this pretty quick, because this is a linear regression. Think on it. You get some inputs, you want to produce an output, and you calculate some weights, you calculate some importance of that variable in order to produce this output, right? If you are predicting whatever, the number of people coming to the building, okay, what are the main variables? Temperature, the weather, blah, 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 and eventually you get a good variable. But at some point, we gave the algorithm the capacity to create abstraction. We allow the algorithm to create an intermediate computation, an amorphous computation, and a non-explainable computation, complete abstract, but very useful in order to get more precise outcomes. And the good thing that was understood in the time is that eventually this layer can be ascending. And if you get enough data, eventually the network can convert to some set of weights that create these abstract numbers that eventually get to a very, very precise outcome. And we see it. We see it how good computer vision works, for example. It's a good example of that. Do we understand what's happening in network? We do not. It's the same as our brain. If we take a a final in the middle between the input and the output, probably will not understand, right? So the analogy is easy. This is how the brain works? No, it's a very, very simplistic model, but it's inspired on how the neural network, right? So this was the revolution. It started in the 80s, but finally it's in the last years that for the first time we were able to exploit that, and this is the revolution we're living these years. Just to get an idea, this is a very well-known data set called MNIST that is all the handwritten numbers. And you will see, this is the input layer. It's a 40 by 40 pixels board where we will write all the manuscript numbers, 1, 2, 3. And we'll see how it creates a first layer, a second layer, and an output layer where we can tag if this is a 1, a 2, or 3, or whatever. So you see, in the first layer, we only have the number being written. But look how this creates a second layer, completely abstract. It's not we cannot understand. What is this? Life, shadow, red, shadow, red, shadow, red, shadow. In this layer, it's a second layer. So an abstract layer creates an abstract layer. So this is the abstract of that. That's not understandable. It's light shadow, red shadow, red shadow, and all the number 9s look similar in the second layer. So if your 9 is more round, more large, more fat, all the 9s look similar in that way. They look very different here. They look some different here, but they look very, very similar at this layer. And finally, they look exactly similar at that final layer. This is somehow how the neural network works inside. And this is not only a technological revolution, it's also a political revolution. And this moment that probably you remember is where AlphaGo beat the champion of Go in 2016. This moment is called a Sputnik moment because it somehow resembled in the Cold War where Russia started winning the space career, right? When they put the Sputnik in orbit for the first time, when the first country to do it, well, now they think that Western created this technology, and now the East is understanding this as a Sputnik, right? So the Western created a Sputnik, and now Asia is that's why they are so focused on owning the AI because of that moment. And there are many books that are related that narrate this moment. And I also suggest to see this movie. It's an AlphaGo movie. You'll find it in YouTube. It's very, very good to understand the process we're doing. Okay, let's talk about Gen AI. And I love this experiment. It's called Deep Green. It was the first experiment where they try to replicate the same thing that when you see the clouds, eventually you see, there's a dragon, and this is the mouth, etc. Right? Have you done that? No? Only me? So we are hallucinating. And this was using the ResNet is a neural network that is publicly available that it classifies images. You gave an image of a dog and it puts the tag of a dog, blah, blah, blah. We have many, many objects being trained on. And we gave a photo of the sky with clouds. It's not an object that it knows. But it started to say, hey, I don't see anything but with that 0.0001%, I see kind of a dog. Okay. They feedback the network with the ability to, okay, let's move some pixels by yourself, move some pixels, so the score of finding a dog somehow increased. And we gave this, and it started to do it repeatedly, and at some point appeared a dog, a very strange dog with 3 ears, 4 eyes, very, very strange, it was an hallucination. But we used to see the hallucination as a bad thing. when ChatGPT hallucinates, we say, oh, okay, this might be a mistake. But eventually, hallucination can be useful. This is my country, a photo in the 50s that was colorized. Were these the colors at the time? Nobody knows. Nobody knows. But how it looks? Well, looks reasonable, looks harmonious. But where are the colors? We don't know. They are hallucinated. But look how the hallucination can be controlled. Right? When you prompt, what are you doing? Are controlling this hallucination. So we are starting to domesticate hallucination. And this is probably the key of the application we'll see in the future. Here are some examples. Write a slogan for an ice cream shop. We serve smile with every spoon. Not only reasonable, but also sounds good. Use an analogy. Wow. Text to code, right? Coders are very bad at documenting what they write, right? But now, eventually, we will only need to write the documentation. And the code, that is the easy part, leave that to the AI. Right? And this is probably the first really impacted industry is code writing. Software engineering is the very first industry really impacted by AI. Fortunately, it was a space where the lack of programmers was so big that it was not replaced. It was just to fill a space that we were not able to fill, right? So hardly impacted the industry. Text to image. Draw an avocado-shaped armchair. And why I like this example? Because I'm pretty sure that in the data set there are a lot of armchairs. I'm pretty sure there are a lot of avocado, but I'm almost sure, I need to confirm, but I'm sure there's no avocado armchair. And now you have this beautiful images completely hallucinated, completely plain. Did you see Sora, the video model of OpenAI? So a drone view of the waves crashing against the cliff, blah, 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 blah. Look at that. Completely generated by using that prompt. And it kind of feels like it understands the physics, understands gravity, understands the fluid mechanics. Look at that, the way it moves. Respecting the gravity, respecting all the things. Wow. Only by seeing many images, many interactions of objects, somehow, eventually at some point, and somehow discover the natural laws. We don't know. We actually don't know if this is doing the way we as humans did to understand how the wave moves. But it did. We don't know how, but it did. And I'm not going to create the sound, but you can also create your own soundtrack. Okay, I want to do a song that for the first 15 seconds very calm, so then it starts getting faster, blah, 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 and you can start creating your own thing. Will we become dumber by using the things? I don't think so. I think we will, of course, we will turn off some parts of our brain. I'm sure. But like driving a car, getting directions, etc. is only a part that is being absorbed and getting into the blood. But with eliminating parts that, at least in my case, I turned the music off in my life. To play music completely in my life very early. Now I can start to feel competent in music, in video, in images, in etc. So I think we will turn off some light and we will turn off some others. It's my view of it. I'm very optimistic, always. Okay, and I want to see that if you have not seen, this is the Salman Khan, the creator of Khan Academy, and now the Khan Migo, the AI, the Gen AI powered tool. And look at how it works. It's let's see, his son, and let's see.
Son, and I'd love you to tutor him on this math problem, but don't give him the answer. You can ask questions and nudge him in the right direction, but I really want to make sure he understands it himself. And he's here in the room, so you can talk to him directly.
Of course, I'd be happy to help. Let's look at the problem together. Can you first identify which sides of the triangle are the opposite, adjacent, and hypotenuse relative to angle alpha?
All right, so I'm pretty sure this is the angle alpha right here, right?
Perfect. Correct. Now, looking at the triangle, which side do you think is the hypotenuse? Remember,
Yeah.
the hypotenuse.
I'm not totally sure. I think it might be this one, but I really am not sure. This side AC.
You're close. Actually, side AC is called the adjacent side to the angle alpha. The hypotenuse is the longest side of a right triangle and is directly opposite the right angle. Can you find which one is the hypotenuse?
Oh, okay, I see. So I think the hypotenuse is this really long side from A to B. Would that be correct?
Exactly. Well done. Now,
So Gen AI, when it appeared in October 2022, were text only, right? In all the examples I gave you, they all started from text to image, text to video, text to sound. But here now, the instruction, the prompt is being by voice and drawing. So it's the most natural interface to access any digital tool. And that's why this is the technology most fastly adopted by 1 million, 10 million in the population, or whatever, however you measure that. So, and also, this is probably the key in teaching and learning, and all professors, we know that all students learn in a different shape, but we were not able to have an instance to provide a personalized education at scale and at low cost. So for the first time, we have an instance that can provide massive personalization at low cost and scale. Right? And this is the tool that we're trying to have at our end. Those are early examples. Actually, Salman Khan had access to GPT-4o earlier than us. But now this is becoming available. We are seeing this first examples, and I think the implications of this will be big. All in, not only in education because we all understand, but move this to all the industries, and I'm pretty sure we will start to see amazing things. Very quick. Hi, here I just had an accident, wanted to report. Okay, are you all right? Are you in a safe place to have this conversation? Yes, I'm fine. Yes, I'm fine. Thank you. Blah blah blah. And here's the interesting part. You can start giving instructions. Okay. It's trying the main result of the conversation. Second, the sentiment of the captain. How did the agent handle the conversation? Blah blah blah. Click, and it goes back with an answer that is based on the prompt. It's based on the data on the prompt. So this is a regular transcription, and now I get the main reason of the conversation is to report an correctly. The sentiment of the customer is that was taken back, but okay. 4, why 4? Because I need taste, I need the trick. So they are very obedient as well. So 4, the agent handled the conversation well and was empathetic. I think that's amazing. How it associated this conversation with empathy. But it did. Right? So this is the power of Gen AI. And this is a tweet from Sam Allen. Writing a really good prompt is becoming a high level skill and an early example of natural language programming. And this is one of the directions of the future, having natural language programming. What Salman Khan did, what they did Salman Khan, he just prompted a persona. You will be a teacher, you will teach my son. You will not give him the answer. Hey, GPT-4, you are very smart. I know you know the answer, but I don't want to give the answer. Just nudge him in the right direction. Beautiful. So we will start to program in natural language, and this is a revolution. The number of digital solutions we have should increase very fast. This is a very important pattern. It's called RAI. Why is this important? Because fortunately, ChatGPT have never seen the EY information. Fortunately, because we have contracts and we will get to jail if eventually that happens, right? So fortunately, ChatGPT have never went into our private and the private data at this university and the hospitals, etc. But eventually, we can create an architecture that uses a very old technology called search engines, same as Google, that can get into your data, retrieve the top 3 results. So for that question, probably those are 3 books that you need to see. Give this book back, and let's create a prompt that has 3 parts. Hey, you are an expert educator, thinking of Northwestern University, or EY, you are an expert lawyer of EY, and we want to provide an answer to this question based only and exclusively on these 3 private documents. And we will send that to an LLM, obviously a private LLM, a paid LLM, not the freely available, to a private LLM, and we'll get an answer. And this answer will compound 2 things. All the knowledge will come from EY, and all the reason will come from the LLM. So LLMs are very fragile in knowledge because of its structure. They only say weights. They do not have a good file system. They do not have a good database system. It's only weights, right? But we will compound knowledge from curated bases and reasoning from the LLM. And I think this will be one of the keys for the future. Just announced yesterday, copilots and agents will probably be one of the path for the future. Create specific domain agents, an educator agent, physician agent, coaching agent, and eventually this agent will start to interact. My compliance agent will talk to the lawyer agent, and eventually they both will give me a suggestion on how to write better an email in the context of EY. This is more or less the future that they will convey this week in the Microsoft conference. I'm just gonna skip. This is one of the good uses that I've seen. For example, in Power BI, today all applications will have a copilot. So of course, Power BI will have a copilot. This is one of the things that I like is based on the data. What questions are likely to be asked by the leadership to me? So I'm gonna provide this presentation to the leadership. What are the questions they probably will ask me? So you can prepare for the presentation much better. On your way to the presentation, that you are very nervous, you can get that. What are the questions they will probably ask you? Try it, and they provide you very, very good questions, and not only questions, they can suggest your answer. So they should really prepare you for this complex meeting, right? How we see EY working on this? First is taxes. Okay, EY have a corpus of many tax declarations in different countries, different scenarios, and of course we have created a copilot. First, for our employees, our staffs can now have a senior advisor in taxes that can check with whom you can check your things. But later is thought to be released to clients as well, to have a tax expert giving opinion and helping you to file taxes. Financial report narratives. How much time are we spending on creating narratives about the financial position, a financial element, and it can be personalized for every client, right? So this is one of the uses EY is giving to Gen AI on creating narrative on financial reports. SAP chatbot. One of the biggest complaints about the SAP are the interface. The interface, nobody really likes the SAP interface. It's very complex to navigate to the right transaction, etc. What if we chat with SAP? So this is one of the products that is also being developed. For now, they're getting very, very good results because we're changing the interface from code instruction routes to regular English language. FP&A, of course, financial planning and analysis. ESG misalignment. What is a compliance finally? What is the compliance work? It's basically to check our production in terms of the current regulation, the current normative, or your own politics. Is this a compliant with your policy? Well, for now, the only way we have to do is to have an expert to check the two documents, see if they align. Well, now we have an automatization that can do that. Okay, let's talk very fast about management. First, one of the things that learned from the IT era is that we no longer want to centralize the development of AI. AI needs to be distributed, cannot be concentrated in one area, because if we concentrate, eventually we create a queue of people in the line to be served by this unit. And one of the things we learned is that IT at some point became completely overwhelmed by requirements and they were not able to prioritize more. So in the AI and starting analytics, we are trying to see the technology not as a technology and control, not as a light, but as a how's the name? Roundabout, where we can all coordinate among ourselves. This is more or less the idea of how to create the COEs, the centers of excellence. So in AI specifically, COE is a very good way to coordinate internally in order to follow some shared principles, but not centralize the control in one single area, because otherwise we will not keep the pace of the advance of the technology. Why is this important? Because it establishes a dedicated hub to coordinate the efforts of the organization, create a unified view of AI within the organization, create standardized practices, because it's not concentrating is the only way to standardize practice. You can also do by policies, by good practices, etc. And this is the idea of SEO. Manage the relationship with external parties, universities, etc. Scale the effort. So if one thing works in one area, try to share this to other areas and to scale properly and improve the acquisition and development of talent for the organization. So COE is one of the things, the trending things that the organization are seeing on how to organize themselves to take advantage of AI. But I told you, first, what are the implications of AI? First, we will be able to solve the things that we do not know how to solve, and I show you some examples, but we need also to take care of this, of first. Are the AI solutions first? And here are some examples. If I write, she's an engineer, he's a nurse, I translate to Turkish, and from Turkish, I give it to English, and it completely changed the gender of the phrase. He's an engineer, she's a nurse. This is an implication of a solution that was not written by, the code was not written by anyone. It was completely self-written. So who to blame about that? Google? The data set? I don't know. Nobody knows. So those are the type of things that we no longer can relegate responsibility to Google. Now, if we are creating a solution that embeds some of the technology, we will need to make some checks, some controls in our solutions in order to control that. Otherwise, we'll be in problems. Reputational problems will be eventually legal problems. And of course, with our clients. This is other example in face recognition. At some point, we started requiring more precision to the machine, more precision to the machine, more precision to the machine. And eventually the machine, now when it rolled that, decided that, okay, I will highly specialize on white men. At some point, it created a branch that started to be unfair. So will we blame IBM, Microsoft, or Facebook? No. And this is the responsible AI trend. Everyone that embeds an AI solution will need to create some controls before releasing the solution. And this is also not only becoming a good practice, it's also becoming part of the regulation of AI that are starting to appear in the world. Europe was the first, USA then, and the rest of the country are ramping up on creating regulation for this. And this is a framework that we use at EY on how to check all the checkups that we need to do on a solution before promoting to the product. Performance, it needs to perform. It needs to be good. It's not good enough, it's still compared with the program solution. Let's keep with the program solution. Keep working, keep working, keep working. If the performance is not good, do not do it. Second, you need to be impartial. It's our responsibility, not Microsoft's responsibility. It's our responsibility to check that it do not create unfairness. It needs to be resilient. It cannot be unsafe. It can be protected from unauthorized use, etc. Explainable. This is complex because I told you that this is unexplainable. So what it means explainable? Well, at least the criteria, the data, the documents, you need to be able to explain what were your sources, what were your posts. And finally, transparent in terms of letting the user know that is interacting with them. Those are very basic principles, but at least it's our first guide on a checklist of the things we need to check before promoting something to production. Okay. I'm saying I'm on time, so thank you so much, and happy to have a discussion now if we have some time.
I think we have some time. Thank you, by the way. Any questions for Patricio?
Sure.
Do you think the need to learn coding languages will go away with time?
The rest of the language?
Yes, basically coding languages, Python or anything. The need for people to learn it will go away because right now with AI you can write anything in English and then it can help you.
Exactly. Do we have enough code written? Yes. And actually, they took GitHub initially to take massive set of codes. And now they must use translate from English to Spanish. You can translate from JavaScript to Python, from Python to C++, etc. So, in my opinion, and it's a thing of the programs right now. First, if you will write some code, have a copilot. So I think it will become at some point unethical to write code by yourself. You need to have a copilot because it will give you quality assurance, will give you some insights on, hey, don't use that function that it's unsecure and eventually will create a cybersecurity issue in the future, etc. So first is if you will write, use a copilot, and second, probably we will stop some point the writing human code. Because it will not only be able to give the right instruction, it will also take care of things that you can miss, like a scalability issue, cybersecurity issue, etc. So that's why I say at some point we become unethical, like in private hand. I also think at some point we'll be seen as unethical.
We've had guests from Google that told us that 25% of their code is already being written by machine. 40% of all the code in GitHub is already written by a machine.
Yeah, absolutely. Yeah.
Do you think that at some point the evolution rate of technology will be kind of matched with the adoption rate of that technology? Because thinking in my own experience, during this year, around June, my former employer participated in a selling corporate process, and it is funny because the question that the auditors did to us, that actually our auditors were EY, was the question from the first wave. So I feel like even though the technology has gone so far, a lot of companies still do not adopt them.
I think it's still an issue, the adoption, because we see relatively clear because we are in the fields. So we are looking at this, and we're looking at the advance. These machines still fail a lot, right? So that's why this complete revolution has not arrived yet. But we are seeing very clear signs of where this is heading, right? I told you, I was in the Microsoft conference, everything seemed to work. Then when you try, well, you see that they are still failing, but you see a clear direction. Things are improving. We see that what we saw in 2022 now is completely improving in 2024. And what we failing in 2024 will be improving in 2026, right? So adoption is still an issue, but I think signs are getting very clear that the need of starting transforming the rate.
Yeah. So with the advent of AI, I just need to understand the kind of projects now that the starting from are getting in this case, how they changed, and if so, how?
Well, yeah, I try to show you some of the examples we are seeing. The consulting business in general, I think, is threat, right? Because we used to sell many managed service by the hour that we definitely become an agent. So most of the services we provide will be an agent. So now we, as all the business, as a threatened industry, we're trying to create the agents and be the first movers on creating agents that create a more efficient delivery. This is more or less how we are seeing.
First of all, it's a great session. How you connected from BI to AI. It's like the connecting the dots is so nice. And my question is, to be an AI consultant, do we need really need to deep dive into hands-on coding, and you need to learn every model and how to train that? All these things are required, or just knowing what's happening in the industry, getting, I mean, knowing everything. Every week we'll be getting some AI news in the market. So,
Yeah, I see.
And and then as an MEM student, how can we be a consultant? What are the tips and tricks that you use to give us? Is there any certification or any courses that we can enroll and quickly of time?
Sure. I mean, I think there are two parts of the answer. First, in order to unlock productivity, probably agents and that things are all what we need. There's a lot of productivity that can be unlocked right now with the tools, and what I'm seeing is that these tools like Copilot and agents, they are doing big effort to make it very simple, very low code, and eventually no code. Or what I was saying this week is even no code, and I think there's a big productivity increase that can be unlocked with it, and this will only require management. To create teams, to create a conveying a vision and move forward on that. But there are some signs that we have reached a plateau in productivity, at least in productivity of the algorithms, in terms of pre-processing. And there are some signs and mentions of the top 3 leaders developers that they are probably it already reached a city. So there are breakthroughs in the future that probably OpenAI have foreseen already. That's why they talk about AGI, but it will require some breakthroughs. So the advanced companies, I think, still need to get into the code. Okay, but for the biggest part of our company, 90%, we probably will need to start creating the management practices to unlock the value.
What do your day-to-day life look like? What are the tasks that you do as an AI lead consultant?
Well, I lead a delivery team. It's like 600 people in Latin America delivering this type of project. I've seen a change. We used to be the model builders, and at some point we started to be those that exploit the pre-trained models to create solutions. So it has somehow changed. I used to have the biggest part of my team in data science, creating models, and I'm seeing a shift of, okay, in not all the words we will train a new model, we will start to use pre-trained models. This is like the shift that I'm seeing in the last years.
All right, let's thank Patricio for his time today.
Thank you.
And as a token of appreciation, here's a gift from MEM, so.
Thank you so much.
Thanks for coming out. I know MEM students and faculty and guests are gonna be looking for lunch. Lunch is gonna be across the street, starting at 11:30. Across the street, meaning the Great Room, which if you don't know where that is, it's literally behind that steeple in the church across the street. So it's very easy, very convenient. We'll have a buffet lunch and in celebration of Thanksgiving, I'm going to talk about the holiday. It's not necessarily a US holiday, but it is a holiday that we recognize. So I'll see you guys there at about 11:30. We're going to try to take pictures over there, right? At some point.
Yeah, we'll try.
Okay.
We usually get a couple of them. And,
Okay.
I do want to say that if you've not signed in, please make sure you sign in. And I also want to mention that, this is just an MEM event. So if there's any non-MEM students in the room, I'm sorry, you don't have enough food for everyone, but, it is just an MEM only event. And that's all I have.
Okay, and I want to recognize Jennifer Way. Jennifer comes to us from the Industrial Advisory Board. She's the chair and also an MEM alum from what year? Roughly the same year?
2014,
14.
full year after.
Okay. Excellent.
And she
So
will be at our event. So if you'd like to talk to our IAB chair,
there's
and have a little
I will
lunch and chat.
talk to me while you eat.
Right.
Okay, all right, thanks again, and I'll see you across the street, okay?
Thank you.
Yeah.
Yeah, that's good.
So we recording.
Oh.
This is Professor in Keller.
Hi.
How are you? I'm good. Thank you. I'm also.
There's the correction. Sorry, is that part of the